Good evening, scholars. You are welcome to the day 5 of the 2026 JAM and Waec Chemistry Masterclass. And in the course of this live class, we are going to look at the topic Stoichiometric Calculation. Again, just to introduce, my name is Michael Warren, and I'm the lead tutor at Warren Science Academy. So for those just joining us for the very first time, I welcome you specially to this channel. And if you have been with me on this channel, I also welcome you to this channel. So in the course of this video lesson, again, we are going to look at the topic stoichiometric calculation. So I will implore you and I will encourage you to get your writing material. Why? Because we are going to do a lot of calculations. So it is very good if you get yourself engaged and active with this particular topic, so that at the end of the day, you will get a lot and benefit maximally from this class. So the class promises to be expository and also comprehensive. So let's get started. So this is day 5 of our chemistry masterclass, and in day 4 we looked at stoichiometry, or stoichiometry as it implies. We look at what stoichiometry is, where we basically defined it as the mass to volume relationship. But in the course of this class, we are going to look at the aspect of stoichiometry that have to do with calculations. So in the course of this class, we are going to look at how to balance chemical equation, because for you to solve any stoichiometric question that has to do with a chemical reaction or an equation, you must first balance that equation, because it is from a balanced chemical equation you can then proceed to derive every other thing you need as it pertains to that particular question. So a balanced chemical reaction is very, very essential in any exam question you come across. Secondly, we look at stoichiometry proper. In the course of stoichiometry proper, we are going to look at the relationship between mass to mass. So we are going to look at the relationship between mass to mass. We are going to look at the relationship between mass to mole. We are going to look at the relationship between mass to mole. We are going to look at the relationship between mass to volume, and also we are going to look at the relationship between mole to volume. So this is what stoichiometry is all about. We are going to look at these 4 concepts: mass to mass, mass to mole, mass to volume, and then mole to volume. So, and for we to be able to do this, we must first balance a chemical equation. So that's the essence of knowing how to balance a chemical equation. Then we look at what we call limiting and excess reagent in every chemical reaction. Then look at the concept of percentage yield, and then we move on to look at what we call water of crystallization. And the 6th thing we are going to look at is concentration, where we are going to focus on the type of concentration we have, which we call molar concentration, and then we forge ahead to look at what we call mass concentration. So we look at concentration in the course of this class. Then look at what we call the titration formula, and some people can call it the acid-base titration formula, because here we are talking about titration. But though it goes beyond acid and base, sometimes it could be an acid and a triazocarbonate. But what we are just looking at is the titration formula. And lastly, we look at what we call the dilution formula. So scholars will begin this class by looking at how to balance a chemical equation. So what is a chemical equation? A chemical equation is simply a representation of a chemical reaction in which you have the reactant on the left hand side, and then you have the product on, you have the reactant on the left hand side, and then you have the product on the right hand side. So simply put, we have this. So let's take this. Let's see. So we'll start by looking at how to balance a chemical equation. But before we do that, we just have to understand certain things that concern this chemical equation. So we are looking at balancing chemical equation. So what's a chemical equation again? A chemical equation, like I said, is a representation, because we are not seeing it, we are just representing it mathematically or in a written form. So we have, let's say, A plus B with an arrowhead to give us, let's say, C plus D. So what is a chemical equation? Again, it's a representation of the reactant, how they react to give us the product. So for most chemical reactions, because in some cases it can be the reverse. So for most chemical reactions, we have what we call the reactant on the left hand side. So we have the reactant here. So this is the left hand side. Then when they react or when they mix, they will give us what we call the product. So these are the products. So the products, we have them on the right hand side. Usually, because in some instance, the reactant can be here and then the product can be here. And those cases is, or they happen with what we call reversible reaction. A good example of reversible reaction is this, where we have nitrogen reacting with hydrogen to give us ammonia. Now this reaction is reversible in the sense that the reaction can proceed forward and backward. So this is NH3. Though this reaction is not balanced. But now what happens is that in this case, nitrogen will react with hydrogen. So in this case, they are the reactant. So when they react, they will give us ammonia. So on the reverse, ammonia can decompose, like it can break down to give us nitrogen and hydrogen. So this kind of stuff is what we call a reversible reaction. So in this case, when we are going back, this is not the reactant, so it will form these guys, the product. So on the reverse, on the or in the forward reaction, these are the reactant, this is the product. For the backward, this is the reactant, then this is the product. So essentially, what we know is that a chemical equation is just a representation of how reactant will react to give us what we call the product. And usually, the reactant on the left hand side, while the product on the right hand side. So there are so many things about a chemical reaction. Number one, a chemical reaction can tell us a lot of things, from the mole to the mass, even to the state of matter. Now in some exams, you could see that they could write something in brackets, G, G, G in this case. G just stands for gas or the gaseous state. In some cases, you will see L, where L stands for liquid. Then we have AQ, where AQ stands for aqueous. Then we could also have S in bracket, where S stands for solid. So a balanced reaction can tell us a lot of things, like I said, from the mass to the mole to the volume, to even down to the state of matter of the reacting or the product themselves, to the reactant or to the product. So now we are looking at balancing a chemical equation. Now one common thing you should know about a balanced chemical equation, which you could be asked in the exam, is that why do we balance chemical equation? We are balancing chemical equation because we want to obey one particular law we have in chemistry. And what is that law called? That law is called the law of conservation of mass. So take note of that. That law is called the law of conservation of mass. The law of conservation of mass. Now, what does this law state? The law simply states that mass can neither be created nor destroyed. Full stop. That's a very easy law. It simply states that we cannot create mass and we cannot destroy mass. So what does it imply? It implies that, let's say for example, we take a substance, 2 grams of a substance at the beginning, 2 grams of a substance, and then we add it to 3 grams of a substance. At the end of the day, I should have 5 grams. This implication. So 2 plus 2 will give us 5. So at the end of the day, I expect to see 5 grams. So it simply says that you cannot destroy mass and we cannot also create mass. If I create mass, for example, it means this will be more than 5. Let's say 6. If I destroy, this will reduce. So in essence, if I take 1 gram of a substance and add it to 1 gram of another substance, at the end of the reaction, I should get or I should produce 2 grams of that substance. So that's the essence of balancing a chemical equation. If your equation is not balanced, you are not obeying the law of conservation of mass. So in essence, we balance chemical equations so that we can obey this particular law, which is called the law of conservation of mass. And again, this law states that we cannot create mass and also we cannot destroy mass. So we are going to look at how to balance chemical equations. We are going to take 3 questions and then we'll move on to the second heading. So let's take our first question. So let's say we have this. So let's start with this reaction. Here we have nitrogen gas plus hydrogen gas to give us NH3. So this is the first question we are going to look at. Now, when we look at this equation, we are going to check, is it balanced? Now, what makes an equation balanced? An equation is balanced when what I have on the left-hand side is just equal to what I have on the right-hand side. So in that case, you can say that reaction is balanced. But if it is not, if what you have on the left hand is not equal to what you have on the right hand, that equation is totally not balanced. So now, when we look at this, we have 2 atoms of nitrogen here, but here we just have 1. So 2 here, 1. So you can see that there's a difference, so it's not balanced. So we are going to work on this. For hydrogen, we have 2 atoms here, we have 3 atoms here. Again, both elements are not balanced on both sides of the equation. So we are going to balance this entire reaction. So now let's go. Now, how do we balance it? We are just going to use a simple method. And what's that simple method? I call it the algebraic method. Now, why is it the algebraic method? Because algebra in math simply means using letters. So we are going to give each of them letters. So A, I'll start with A, then B, then C. So we are just using letters to balance a chemical reaction rather than to start thinking, should I add 2? Should I add 3? Should I add 5? To cut off those long processes, we just simply use what we call the algebraic method. Now, what the first thing you do, you give them letters, and that's what we have done. So the next thing you are going to do is that you are going to identify the element present. Again, first, give them letters. Secondly, identify the elements that you have that are present. So the element present in this reaction are just two elements. We have nitrogen, and then we have hydrogen. So these are the two elements we have in this particular reaction. So nitrogen and oxygen. So we'll start with nitrogen, then we'll move on to hydrogen. Now for nitrogen, we have 2 atoms here. So 2 times the letter beside it. That's 2 times, so will give us 2A. Then this is equal to, then we'll come to this, for the product, we have just 1 atom here. 1 times C will give us C. So we are done with nitrogen. So we move to the next element, which is hydrogen. For hydrogen, we have 2 atoms here. Then 2 times B will give us 2B. Then this is equal to here. So for hydrogen, it is 3 atoms. But 3 times C before the compound is 3C. So this is first. This is second thing we are going to do. First, give them letters. Then secondly, identify the element present. Then the third thing is that use their atoms to multiply the alphabet you have beside it. Then from here it becomes easier. So when you get to this part, what you simply do is that pick any of the alphabet. It could be A, B, C. Even if you have D, you can pick any of them. And give them a value you choose. But for me, I prefer going with 1. So I'll pick A. So in this case, let A be equals to 1. Again, this rule is not rigid in the sense that you can pick B, you can pick C, you can pick D. And also you can give them any number based on what you want. But it's very good to pick the smallest number so I don't have to start dividing at the end of the day. So the smallest possible number I can give to them is 1. So when they are done, you can now come back here. Remember I said let A be equals to 1. So for this first equation, the equation is 2A is equal to C. And A here from what we said is 1. So this becomes 2 times 1 is equal to C. Then when we multiply, this will give us 2. So therefore C is equal to 2. So we now have B left. So that equation we have here is 2B is equal to 3C. So now C is 2, that is C. So we have 2B is equal to 3 times C is 2. So 2B and 3 times 2 give us 6. And I'm going to divide both sides by 2. This will cancel this. So C divided by 2 give us 3. So therefore from our calculation, B is equal to 3. So now we have A, we have B, and then we have C. So we are done with it. So what we just have to do is just to put in this value back into this equation, and then that's all. So now for this first one, A is 1, so 1 it's not really significant. So I can just write as N2, no need to write 1, plus B is 3, so I must replace that B with 3. So 3H2 to give us C is 2, so that will give us 2NH3. So at this point, we are done balancing this chemical reaction, but we can check if we are correct. Now for nitrogen here, it's just 2 atoms. So we're going to check. For this side, we have the 1 here. 1 times 2 from nitrogen is 2. So 2 atoms of nitrogen here, 2 atoms of nitrogen here. So that makes nitrogen balanced. But we must check for hydrogen. For hydrogen, 2 times 3 is 6. And similarly on this side, 3 times 2 is 6. So the equation is balanced. So with this method, you can balance any chemical equation, no matter how long it is, at a very simpler and easier way. So let's take a second question, which is the formation of water. So let's go. So we are going to use another simple equation just to understand it. Now, the second question we look at is the formation of water. During formation of water, hydrogen will react with oxygen to give us water. So this is how water is formed. But just writing it like this and taking a close look at it will tell you that this equation is not balanced. So what does that mean? We have to balance the equation. Now when you look at it closely, we have 2 atoms of hydrogen here, 2 atoms of hydrogen here. We would have said that the equation is totally balanced. But let's check for oxygen, because Both all the elements must balance. If I have 2 atoms of hydrogen here, I should have 2 atoms of hydrogen here. If I have 10 atoms of oxygen here, I should have 10 atoms of oxygen. If I have 3 atoms of chlorine here, I should also have 3 atoms of chlorine. So all the elements must be balanced, not just one. So, but for this case, hydrogen is balanced. But let's check for oxygen. For oxygen here, we have 2 atoms here, but here we have just 1 atom. So it means this equation is not balanced. And what does that mean? We have to balance the equation. And again, what's the rule? We are using the algebraic method. And the first thing you ought to do is that you are going to give them letters. So we'll do that. So this is A, this is B, and then this is C. So I've given them letters. Now the second thing I should to do is to identify the elements that are present. So the element present here are hydrogen. So we have hydrogen, and then we have oxygen. So you just identify them. Sometimes it can be up to 4. Write the 4 elements you can find. So hydrogen, oxygen, that's all. So next you multiply each of the atom with the letters beside them. Hydrogen 2 times A give us 2A. Then these are equal to there's no hydrogen here. So for this side, 2 times C will give us 2C. So that's for hydrogen. Then for oxygen, this is 2 times B, 2B equal to, here is just 1 oxygen, 1 times C, that's C. So with this, we have written out what we need to solve. So the fourth thing I told you to do is to pick any of the alphabet. It can be A, B, C, D, E, F, depending on whatever you have. Pick any of them and make it to be equal to 1. So I'll pick A again and make it to be equal to 1. So in this case, let A be equal to 1. So let's keep this aside. So let's have this our first equation. First equation here is 2 is equal to 2C. Now A here is 1, so that's 2 times 1 is equal to 2. C we don't know. But 2 times 1 is equal to 2. This is 2C. We are going to divide both sides by 2. Don't divide. 2 will cancel 2. Now 2 divided by 2 is 1 is equal to C. So automatically you can tell that C is equal to 1. So that's the final answer for C. So we have one more equation there, which is this. So for this equation, we have 2B is equal to C. So what do we have? We have C. So we have C as 1. So this is 1. So what we are going to do is we need B. So we are going to divide both sides by 2. So this will cancel this. So B is equal to 1 over 2. So now this makes it interesting. Why? Why is it interesting? Because we have a fraction. So what do we do if we encounter this? So there are some questions you will solve when you balance them. When you try to use this method, you get a fraction, but don't be afraid. There's something you simply do. Now, I'll write all the answers. So we have A is 1. Now B is 1 over 2. Then C is 1. So this is what we have. So when you come across such thing, because I can't come here and write half, though it's logical, but we just can't write it. So what you do is that you look at that fraction, you look at the denominator. You know what denominator means? In a fraction, what we have above, we call it numerator. And what we have below, we call it denominator. So you find the denominator. If it's just 1, use that denominator to multiply everything. But if you have multiple fractions, you will take the LCM of all the denominators and then use the LCM to multiply everything. But in this case, we just have one fraction. So you just simply pick that denominator, in this case, which is 2. I'm going to use 2 to multiply everything. So this is going to be times 2, times 2, and times 2. But if there are multiple fractions, again, I'm just emphasizing that, pick the LCM of all the denominators, or find the LCM of all the denominators. So the LCM you get is what we are going to use to multiply everything. But in this case, we just have one fraction. So we are just going to use this 2 to multiply everything. Now 1 times 2 gives us 2. Now half of 2, just like 2 will cancel 2, and this will give us 1. Then 1 times 2 is 2. So this is what we are going to use to balance the equation. So coming back, I'm going to replace A with 2. So let's write on this aspect. So we now have 2H2 plus, now B is 1. So there's no need of writing that one. So that's O2 to give us, now C is 2. So that gives us 2H2O. So with this equation is balanced. But let's check. Now when you look, we have 2 times 2 here, and that gives us 4. So we have 4 atoms of hydrogen. On this side, the same thing. 2 times 2 is 4, so we have 4 atoms of hydrogen on this other side. Now for oxygen, we have 2 atoms of it here. And for this side, there's a 1 here. 1 times this 2 will also give us 2. So both hydrogen and oxygen in balance. So in this condition, we can fully confirm that this equation is balanced. So now let's take our third question before we move on to the other aspect. So now for the other aspect, for the other question, we are going to take a look at an acid-base reaction. So let's take a look at this question. So we have an acid-base reaction. For the third question, I want to look at hydrogen chloride reacting with sodium hydroxide. So this is NaOH. And in chemistry, when you read up the chemical properties of acid and chemical properties of a base, you find out that whenever an acid reacts with a base, it will produce two things. Those two things are salt and water. So the two things we are going to get from this reaction is going to be salt and water. So we are going to have salt. In this case, our salt is going to be NaCl plus H2. So take note of that. Hydrochloric acid tells us an acid. Sodium hydroxide is a base. We are going to get sodium chloride and then we are going to get water. So every acid-base reaction will give you salt and water. And this reaction has a name which is called a neutralization reaction. So take note of that. So in the exam, it could be asked, what's a neutralization reaction? It's simply the reaction between an acid and a base. So now let's look at this equation and see if it's balanced. But if it's not balanced, that means we have to balance this chemical equation. Now, looking at this reaction, we look at it. Hydrogen, there's one here, so we have one atom here, and then we have one atom here. So in total, we have two atoms of hydrogen here, two atoms of hydrogen. Now, on this side, we just have two. So we have two. So we have two atoms of hydrogen here, two atoms of hydrogen here. So that's balanced. But let's check for the others. For chlorine, we have just one atom here, and on this side, we have one atom. Again, this equation is balanced. Now, let's check for sodium. Sodium is one atom here, and sodium is one atom here. So the equation is balanced. Then lastly, let's look at oxygen. Oxygen is one atom here, one atom here. So this equation is balanced. That means that we don't have to balance this chemical equation because all the elements are equal both from the reactant side and then on the product side. So equations like this, there's no need to balance. Let me just show you another example. And a good example is this reaction. This reaction, or number 4, let's take that. So this is what called CaCO3. When this compound decomposes, it gives us CaO plus CO2. So this reaction is called a decomposition reaction. Decomposition. So it's a type of reaction. Like I said, for this particular one is called a neutralization reaction. So these are just extra tips you get from this class. So now if you look at this reaction, this calcium, just one atom here, on this side, one atom. So calcium is balanced. For carbon, one atom here, then we have one atom here. So carbon is balanced. But then for oxygen, 3 atoms here, 1 here, so we have 1 here, then we have 2 here. So 1 plus 2 gives us 3. So 3, 3. So in this case, all the elements are balanced. So there will be no need to balance this equation further. So with this, we'll come to the end of how to balance chemical equation. So I will urge you to take your books and then take your past questions. Find as much questions that you see on balancing of chemical equation and then try to attempt as much as possible. That will make you more better, and I hope you do get better. So with that, we'll move on to the second aspect of this class, which is stoichiometry proper. So we are going to look at so many things within stoichiometry. So in fact, that's the basis of this class today, stoichiometry. So that's why we have to learn how to balance chemical equations. So we are going to look at stoichiometry proper. So let's go. So we are going to look at stoichiometry. And again, if you go back to the day 4 of this live class, you'll get to see that we define stoichiometry. And in stoichiometry, we say stoichiometry is what? The mass-volume relationship. So we are looking at the relationship between mass and volume. But like I said in that class, it goes beyond mass and volume. When it comes to stoichiometry, we talk about volume and every other thing that we can come across. So in stoichiometry, we look at relationship between mass to mass, like I said. Here we talk about mass-mass relationship. Mass-mass. We talk about, so let's take this as 1. We talk about mass-mole relationship. Mass-mole relationship. We talk about mole-volume relationship. Mole-volume relationship. So this is what we are going to talk about. We are going to look at mass-mass. We can talk about mole-mole as well. We can talk about volume-volume. So we are just trying to look at relationship either between mass, mole, and volume. No, anyhow we can pair them. But now, what's stoichiometry? And why are we even interested in stoichiometry? Now, let me give you a good scenario. Let me paint a picture for you. So let's say there's a girl called Molar. Now, Molar likes making her tea in a very special way. And how does she like making her tea? For her, she prefers to use 2 sachets of milk and then 1 sachet of chocolate. That's how she prefers making her tea. So let's say for Molar, now pay attention to this illustration. For Molar prefers using 2 sachets, or let's say 2 sachets of milk. 2 sachets of milk, and then 1 sachet of chocolate. And this combination will give us what we call a golden tea. So this is Molar's recipe. Molar prefers 2 sachets of milk and 1 sachet of chocolate. But there's one thing you ought to know. Things in nature is not always balanced, and they don't always come as expected. What does that mean? Oh, Molar likes using 2 sachets of milk and 1 sachet of chocolate. So there could be a day and mom will say, oh, today what I have, emphasis on that, what I have. So what you have at hand is Molar will tell her that, oh, what we have today is 3 sachets of milk, 3 sachets of milk, and then 2 sachets of chocolate. So this is what Molar's mother have. But Molar knows that, oh, if she uses this, she won't get her specialty. So then we have to make some calculation, also amendment. So that amendment we are trying to make is what we call stoichiometry. So we are going to look at it. Or if I use 2 sachets of milk, 1 sachet of chocolate, but in this case I have 3 sachets of milk and then 2 sachets of chocolate, so I can't just combine them together. Then I have to think. So the right thing for you to do is that what we do is simple. What I usually do as a student is I will close this aspect. Then this aspect to me is x. We don't know what it is. So what I'll do, I'll simply cross multiply. I'll simply say 2 times 2, that's 4, divided by 1, 4. It means 2 sachets of chocolate, we go with 4 sachets of milk. But do we have up to 4 sachets of milk? The answer is no. So that's not possible. So it's not possible for me to use 2 sachets of chocolate. So now the next thing we'll do is that I'll come to this side and close this other side and take this as x unknown. So what I'll do again, I'll cross multiply. So it will be 3 times 1, which is 3, divided by 2. That will give us 1.5. So 1.5 is something as 1.5. And this is possible. So it's very possible for me to take 1.5 from 2. So it means at the end of the day, I'm going to use 3 sachets here. 3 sachets here. I'm going to use 1.5 sachets here. So meaning I'll be left with half. So this is what stoichiometry is all about. You are just trying to relate between mass and mass, which we look at in the course of this video lesson, mass to mole, mass to volume, and a whole lot of other things. So we are going to go ahead and solve some questions. So let's go. So now let's take a question. So question 1 on stoichiometry. So calculate the volume of oxygen calculate the volume of oxygen required to burn, or in some exam they use the word combust. Combust means to burn in oxygen. To burn 45 cm3 of ethane. So this is the question we have. In some exams, you could be given a question like this, but in some, they might give you the question because at some point they expect you to know what will happen whenever oxygen reacts with ethane. Is an organic compound. So whenever any organic compound is combusted or is burnt in oxygen, it will give us 2 things. And those two things are carbon dioxide and water. So in this case we have ethane. Ethane is C₂H6. Then it will bond in oxygen. So whenever any organic compound, take note of this, a very, very important thing. For any organic compound that is bound in oxygen, it will always give us two products. What are those two products? Carbon dioxide and water. So we have CO2 in this case, and then we have water. Again, this is where the first topic we looked at comes to play. Balancing of chemical equation. If you clearly look at this equation, we have two atoms of carbon here, we have one here. That clearly tells that this equation is not balanced. Similarly, for hydrogen, we have 6 here, we have 2 here. For oxygen, we have 2 here, we have 2 plus 1, that's 3. So 2 here, 3 here. So the equation is not balanced. Then we have to balance this equation as soon as possible. So, but I'll balance it in a very fast way. So I'm just going to add 2 quickly to this side. Then we have 2 here, then 6 here. Then I'm going to add 3 to this side. That makes it is 4. Is 4. That's 7. So that's 7 over 2. And this is going to be 2. This is going to be 7. This is going to be 4. And then this is going to be 6. So I just have to balance it in a very quick way so I don't end up spending time. So now, if you look at it now, we have 2 times 2, 4 atoms of carbon. We have 4 atoms of carbon, and the equation is balanced. For hydrogen, we have 6 times 2, that's 12. Here we have 2 times 6, that's 12. So carbon is balanced, hydrogen is balanced. Now for oxygen, 7 times 2 is 14. On this side, we have 14 atoms here. Now for this, 2 times 4 is 8, so we have 8, plus 6 times 2, there's a 1 here, that's 6. Now 8 plus 6 is 14, so 14, 14. So after balancing the chemical equation, we have found out that carbon is balanced, hydrogen is balanced, and then oxygen is balanced. So we can then go ahead and solve this question. So I'll take this off, and then we'll proceed. So now, your equation must always be balanced. Don't always forget that when you are given an equation, don't be in a hurry to just go ahead and solve. Check if the equation is balanced. Now looking at it, the question says calculate the volume of what? Oxygen that we need to burn 45 cm3, which is also volume. Now I have to write this equation down because I have to paint a picture for you. So I'm taking this equation down. So we have this 2C₂H6 plus 7O2 to give us 4CO2 plus 6H2. So now the question is asking us what volume of oxygen is required to combust 45 cm3 of ethane. Now why do I have to circle this part? In every stoichiometric question you are given, number one, you are interested in 2 things. So the first is that identify those 2 things. No matter how long an equation is, you are just comparing 2 guys or 2 elements or 2 compounds in that equation. Now when you read through this question, our interest is just oxygen and ethane. So these are our interests. In this case, we have no business with carbon dioxide and we have no business with water. So these are my interests. So we must identify those 2 points of interest. Then the next thing is that what are you even interested in those particular things? In oxygen, we are interested in volume. So here we are interested in volume. And for ethane, they also give us the volume of ethane. So here we are also interested in the volume. So that's the 2 things you just have to know about every stoichiometric question, provided you have balanced the equation. So the first you are going to ask yourself from the question, what do you need? What's your interest and what's your focus? So our interest in this case is just ethane and oxygen. So we have no business with carbon dioxide and we have no business with water. Then what are you interested in those guys? You are interested in volume here and volume based on the question. In some questions you could be asked mass. So let's say if we have the mass of oxygen. So here we are talking about mass and here we are talking about volume. So know what you are interested in. So in this case, this is a volume relationship. Now one other thing you ought to know, if you follow the first class, we said mole is equivalent to volume. In our first class, we said that mole is equivalent to what we call volume. That's what was said in the first class. Now, in this case, we have 2 moles here. So we have 2 moles. We have 7 moles rather. 7 moles, we have 4 moles on this side, and we have 6 moles. But you might be need to write this because we really have no business with that. But if it's in case of Waec, you are going to write it. There's a systematic approach for solving question. We are going to write what we call mole here. In this area, we are going, okay, let's take it in the Waec format. So in the Waec format, this is going to be mole. The next thing I'm going to call mole ratio. Mole ratio. Ratio, just take them and put a ratio. This is going 2:7 ratio. This is 4:6. So now for volume, which we are interested in this case. So for the volume, what we have here is, like we said, mole is equal to volume. So if we have 2 mole, it's also equal to what we call 2 volumes. So in this case, we have 2 mole here, so this is going to be 2 volume. But our unit for volume in this question is cm cube. So I'm going to write as 2 cm cube. We take what? 7 cm cube. So this is what we become. We need volume. So it means that we need 7 cm cube of oxygen to burn down 2 cm cube of ethane. So but in this case, we are asked that what volume of oxygen. So on that oxygen, we are going to put x because that's our question. We burn 45 cm cube of ethane. So this is what we have. So basically, this is our question. So again, these are standard. The standard is that 2 cm cube of ethane, we need 7 cm cube of oxygen, just like Molar's story, where she needs 2 sides of milk and 1 side of chocolate. So this is standard. But now this is what we have for 5 cm cube. So we are going to cross multiply. So when we cross multiply, 2 will multiply x, and 2 times x will give us 2x. And then we are going to multiply 45 and 7. So we are going to multiply that right now. So 45 times 7, and that will give us 215. So this is going to give us 215. I will divide outside by 2. This will cancel this. So then we are going to divide. So divided by 2, and our final answer becomes 157.5 cm cube. So this is the volume of oxygen that we need to burn down 45 cm cube of ethane. So it's just a basic concept. The basic concept is that you just have to write your question and ensure that it's balanced. Then just find what are you interested in and what are you really looking for in those guys of interest, and then you go ahead and calculate, and then you get your answer. So let's take a second question before we move on to the next aspect. So look at our next question. So the second question. So our second question here says, how many grams of calcium triazocarbonate 4, which is CaCO3, will produce 22 grams of calcium oxide? So this is the question we are given. Now it's a very simple question. The question is asking us how many grams of calcium triazocarbonate 4 will produce CO. Like I said, in some exams, you could be given the reaction, but in some you may not be given. That's why, as much as you study, try to know whatever every particular reaction will yield or what they will end up in. Now, for CaCO3, when it undergoes decomposition reaction, so CaCO3, when it's broken down, or let me take it to the next line. So we have CaCO3. When it's broken down or when it decomposes, we produce what we call CaO, and then we produce what we call carbon dioxide. So this is the reaction, and when we checked it earlier, the equation is balanced because 1 atom of calcium, 1 atom of calcium, 1 atom of carbon, 1 atom of carbon, 3 atoms of oxygen, 1 here plus 2 here, that's 3, so 3, 3, balance. So the equation is balanced. Now, when you look at this question, take a close look at this question. We are asked how many grams of calcium triazocarbonate 4 will give us 22 grams of what? Calcium oxide. So we are interested in 2 things. Like I said, in every stoichiometric question, we are always interested in 2 things. Find those 2 things, and you get them from your question. So we are interested in this, we are interested in this, and then we are interested in this. Simple. So for this question, we have no business with calcium carbon dioxide rather. So now, in these 2 guys, what are we even looking for? We are asked gram, and gram has to do with mass. So here we are interested in mass. For this, we are asking 22 grams again, we are also interested in mass. So this is a good example of a mass-mass relationship. So now, but we have to calculate their masses already. So we'll quickly do that. Now for calcium triazocarbonate 4, so this is for, I'll solve it here. So we have CaCO3, calcium is 40, then carbon is 12, then oxygen is 16 times 3. So this will give us 40 plus 12 plus 48. And then when we add this up, we are going to get 100. So this is going to give us 100 gram. So this is going to be 100 gram. So from this balanced equation, I will emphasize again, from this balanced equation. So now for CaO, we are also going to calculate that likewise. So this CaO, calcium is 40 plus oxygen is 16. So this will give us 56 gram. So this 56 gram. So from this balanced equation, you get to see that 100 gram of calcium triazocarbonate 4 will produce 56 gram of calcium oxide. So the question is asking us how many gram of CaCO3. So we'll take this as X. We produce 22 gram of calcium oxide, so 22 gram here. So if 100 gram produce 56 gram, the question is asking us how many gram of this we produce 22 grams. So from here, it's going to be a straightforward question. Why? Because we are going to cross multiply. So let's cross multiply. So cross multiply. So when we cross multiply, we now have 56 times x, and that gives us 56x. We are going to do 100 times 22, and that gives us 2,200. So we are going to divide that by 56. We're going to divide that by 56. So let's divide and see what that will amount to. So 2,200 divided by 56, and that will produce 39.29 grams. So it means that we need to find answer x will give us 39.29 grams. So to the nearest whole number it will be 39 grams. So that's what the answer will be. So it's a very simple case. The simple case is that you are trying to find out what are those things you are interested in, and then what in them you are actually looking for. It could be mass, it could be mole, it could be volume. That's just the basic concept. So now let's take the third question, that's stoichiometry, before we move to other aspects. So our third question we have says how many moles of ammonia? How many moles of ammonia? And ammonia, the chemical representation is NH3. So how many moles of ammonia are produced from 4 moles of hydrogen? So basically, this is the question that you are making. Because it asks us how many moles of ammonia are produced from 4 moles of hydrogen. Now it's a very simple question, but before we do that, we must write the question. So if you are not given, you should write it. But if you are given, then you can move ahead. So, but from this equation, the equation goes like this: it is nitrogen gas reacting with hydrogen gas to produce ammonia gas NH3. And when this equation is balanced, we are going to simply add a 2 here, and then we are going to add a 3 here. So this makes the equation balanced. So now when you read this question, we are asked how many moles of ammonia. So we are interested in this are produced from 4 moles of hydrogen. So we are interested in hydrogen. So in this case, we have no business with nitrogen gas. So we are interested in this and this. And even within those two, we are interested in mole-mole. So this is not a case of a mole-to-mole relationship, mole-to-mole. So clearly from this case, we can see that 3 moles of hydrogen will produce 2 moles of ammonia. The question is asking us how many moles of ammonia X can we produce from 4 moles of hydrogen? That's a simple question. So we are going to cross multiply. So just simply cross multiply. So 3 times x will give us 3x. Then 4 times 2 will give us 8. So we are going to divide that by 3. So I'm going to divide. So let's see what that will give to us. It divided by 3. So we have 2.7 moles. 2.7 moles. So in this case, 4 moles of hydrogen give us 2.7 moles of ammonia. So scholars, I hope you have learned something from the beginning of this class till this very moment. So if you have any question, try to leave them in the comment section of this video as I will go back and check for questions. So in the absence of any question, we move on to other aspects of this topic. So before we move to the next part, which is limiting an excess reagent, I just want you to understand something. We didn't talk about volume in this case, but there's something you ought to know. Rather, we didn't talk about molar volume because we talked about volume. We didn't talk about what we call molar volume. And like I told you in our previous class, or the day 4 of this master class, I told you that the molar volume of every gas at STP, taking of this word at STP, I will say STP stands for standard temperature and pressure, is 22.4 dm³. So don't forget, molar volume of every gas at STP. So the molar volume of every gas, at what we call STP, where this stands for standard temperature, which is 273 Kelvin, and the standard pressure, which is 760 millimeters of mercury. So don't forget that. So from this point, we move on to look at other aspects. I will look at limiting an excess reagent. So I'll go back to my illustration of boiler, its mother, and its golden tea. So let's move to the next aspect, which is limiting an excess reagent. Now you just have to understand something. 2 key points you just have to know in limiting an excess reagent, which you find relevant for your exam. So we are going to look at what we call limiting and excess reagent. Now, when we look at limiting and excess, their name tells us what they mean. Limiting is from like the word limited, which means not enough. It simply means not enough, not in excess. So it's just the opposite of this. When we say limiting reagent in chemistry, it simply means the reagent that is used up during a chemical reaction. So for the excess, it means like a lot. It means during the reaction, there is still more left at the end of the reaction. So for the excess, it is not used up during the reaction. Now, then what's the next thing that is very, very important? Limiting reagent is very, very important. So taking of this, the limiting reagent will determine the amount of product formed. So in your exam, you could be asked, which of the following will determine the amount of the product formed? The answer should be the limiting reagent. So one key point from this class is that the amount of product formed, the amount of product formed is determined by the limiting reagent. Now I'll paint a story for you, or I'll just recall the story I told you earlier about Bola, his mother, and then his golden tea. So let's go back to the story. Remember that Bola likes making a special tea or a golden tea. And for that golden tea, Bola likes using 2 sachets of milk, and then he likes using 1 sachet of chocolate. So this recipe will give him his golden tea. So this is special recipe. 1 side of milk and then 2 sides of milk, 1 side of chocolate to give us his golden tea. So this is what we call a standard. It's a standard. And again, that standard you can only get it from a balanced chemical equation. So it's your balanced chemical equation that will give you your standard. So that's how we talk about balancing of chemical equation at the very peak of this class. So now this is a standard already. So now, like I said, conditions are not always favorable. So in the case where his mom provide 3 sachets, so this is standard. So let's say standard. So this given. She was given 3 sachets of milk, and then he was given 2 sachets of chocolate. Now he knows that if he uses the 3 sachets that is provided there and 2 sachets of chocolate, he's not going to get that specialty he wants. So he's not going to calculate. Again, I'll do a calculation for you. Like I told you, when you encounter questions like this, I just need to take my palm and cover one of the side. So when I cover this side, I'm going to cross multiply. So I'm going to cross multiply like this and then divide it. So whichever side is paired, or whichever side is like which paired side is given. So we have 2 here, we have 2 here. So whichever side is complete, rather, we are going to multiply and divide with that side. So this is going to be 2 times 2 gives us 4 divided by 1. That's 4. It means 2 sides of chocolate will react with 4 sachets of milk, and we don't have up to 4 sachets here. So it's not possible to use this entire 2 sachets. But now when we do it on the reverse, when I close this side, so when I close this side, so I'm going to take side as x. So in this case, I'm going to multiply these 2. So 3 times 1 will give us 3, then 3 times 2 will give us 1.5. So it means in this case, we are going to use 1.5. 1.5 is same thing as 1.5. So we are going to use 3 sides of milk and then 1.5 sides of chocolate. What does that mean? At the end of the reaction, we are going to use 3 sachets, and then we are going to use 1.5, or let's just take it as 1.5 here. So it means at the end, out of these 2, we are using 3, means this is 0, nothing will be left. Out of 2, we are going to use 1.5, means half will be left, half left, 0 left, so nothing left on this side. So now this brings us to the concept of limiting. Limiting means that reagent that will be used up. So in this case, the milk will be used up at the end of the reaction. So it is the milk that will determine how much of the tea you are going to form. So if we have the amount of milk, the amount of tea you get from 3 sachets of milk is totally different from the amount you get from 6 sachets of milk. So that's what we mean by limiting reagent. So in this case, chocolate is excess by how many half? Because we are only going to use 1.5. Meaning half is remaining, so it is in excess. So it is your limiting reagent that will determine the amount of the product that will be formed at the end of the reaction. Just like, let me just paint a good example. Just like you have a cup of rice, and then you have 10 packs of Maggi. You have just 1 cup of rice. but then you have 10 packs of Maggi, like 10 packs. You can't use the 10 packs of Maggi to cook the rice. So it is that it's just that rice you have. You can just take probably 1 cube of the Maggi and use to cook the rice. So it is that rice, that 1 cup that determines how much of the rice you are going to have. So I don't expect 1 cup to give us a big bowl of rice. So with that just 1 cup, I'm going to also end up having a little quantity of cooked rice. So it's not because I have 10 packs of Maggi, that means I'm going to cook a big pot of rice. No, it is that rice that is limiting, that will determine how much cooked rice you are going to have at the end of the day. So this is the whole concept of limiting and excess reagent. But what I want you to get from this class is that the amount of product formed is strictly determined by the limiting reagent. It's a very good question in exam and it could be asked. So save this and let's move on. So the next thing we are going to look at is what we call water of crystallization. So let's look at water of crystallization. So we are going to look at what we call water of crystallization. So now, what's water of crystallization? Again, this is just a theoretical topic, but at some point, you could be told to calculate. Now, water of crystallization is just simply the molecule of water that is chemically bonded to a salt. So just water and there's a salt. The molecule of water that is chemically bonded to a salt. And most times, it's usually separated from the salt with a dot. So for example, you could see compound like this, CuSO4, that's copper tetrahydrosulfate 6.5H2, for example. You will see compound like this. So we call this copper tetrahydrosulfate 6. 5 is what we call penta. So we are going to call this pentahydrate. Penta 5 hydrate just tells that it's 5 molecules of water. So we could have something like Na2 CO3 dot H2O dot, let's say 10, there's a 10 here, dot 10 H2O2. So this sodium triazocarbonate for 10 is what we call deca. So we are going to call it a decahydrate. You can also have something like MgSO4 dot 7H2O. So this is magnesium tetrahydrosulfate 6. 7 is what? Heptahydrate. So this amount of water, this molecule of water that is chemically bonded to this salt is what we call the water of crystallization. And take note of this: when you have water of crystallization to a salt, we call that kind of salt hydrated salt. So we call this kind of salt, all of them down here, we call them what? Hydrated salt. Hydrated salt. Again, it's still clear. Hydrated means there's water, presence of water. So when there's water molecule bonded to a salt, water of crystallization or water molecule bonded, we call this kind of salt water of crystallization. So we call this kind of salt hydrated salt. Then that water that is added is what we call water of crystallization. Then when these water molecules are totally removed, in the sense that the salt is not dry, we call this kind of salt what we call them anhydrous salt. Anhydrous salt. So just to recap, the water of crystallization is simply the molecule of water that is chemically bonded to the salt, and when they are chemically bonded together, we call such kind of salt hydrated salt. But when they lose that water of crystallization, we now call them anhydrous salt, like in a way dry, anhydrous without water. So we call them the anhydrous salt. So I hope you learn something from this aspect. So we want to look at the next aspect. So just to emphasize, in your exam, you could be asked to calculate the percentage of water crystallization. So let's take a good example. Let's take copper, or let's take sodium Na2CO3 dot 10H2. In your exam, you will be told to calculate the percentage of water crystallization. So let's look at how to calculate for that. So percentage, so you're going to write my percentage like this. So percentage WOC stand for water oxidation, is equal to the mass of the water oxidation over mass of hydrated salt times 100, because we are calculating the percentage, so that's why we are multiplying by 100. So now the mass of water oxidation. Now water oxidation is what? 10H2O. 10H2. That's the water oxidation. So now for that guy, let's calculate first. Now we have 10H2O. So this is 10. Let's open a bracket. For hydrogen, relative atomic mass is 1. So this is going to be 1 times 2 plus oxygen is 16. Now this is going to be 10. 1 times 2 is 2 plus 16. And 2 plus 16 will give us 18. So 10 times 18 will give us 180. So the mass of water oxidation is 180 gram per mole. 180 gram rather, not per mole. So 180 gram. So then for the hydrated salt is everything together, because hydrated means there's water. The water will be salt together, that's what we call hydrated salt. So we are going to calculate for that entire mass. So it is Na2CO3.10H2O. Sodium is 23, so that's 23 times 2 plus carbon is 12 plus oxygen is 16 times 3 plus the water oxidation is what we have here as 180. So no need to break that down. So that's 180. So this will give us 46 plus 12 plus 48 plus 180. So let's do the calculation. So here we have 46 plus 12 plus 48 plus 180. So this gives us 286. So that's 286 grams. So now we can now go ahead and calculate the percentage of water oxidation. So we have percentage of water oxidation is equal to the mass of water oxidation, which is 180. So that gives us 180 over mass of the hydrated salt, that's 286 times 100. So therefore our final answer will give us 180 divided by 286 times 100. And with that, we are going to land at 62.9%, or approximately 63%. So this is how you could be told to calculate for what we call percentage water oxidation. So your simple formula is the mass of the water oxidation itself over mass of the hydrated salt, then multiplied by 100, and that will give you percentage of water oxidation. So I hope that makes sense. So move on to look at the other aspects. So if you have any question, any comment, suggestion, please do it to leave them in the comment section. I'll go to the back end and check if there are questions. So viewers, in the absence of any question, we'll move on to other aspects of this class. So we are going to look at what we call the percentage yield, just like what we looked at earlier, which is the percentage of the water crystallization. So we're also going to look at what we call the percentage yield. So let's move on. We are going to look at what we call the percentage yield. Yield. So now, what is yield? Yield is just simply what you get from something. Now let's explain what percentage yield is all about. Percentage yield is just like you expect that at the end of this business, for example, you should get, let's say you started up a business, and you expect that at the end of this business, or at the end of that particular time, you should make a profit of 100 naira. But at the end of the day, you ended up making 80 naira. So what you expect, we call it theoretical, based on your calculation. You'll be like, oh, I bought this stuff for, let's say 15 naira, and I'm selling for, let's say 150 naira. Then you expect that your gain should be 100 naira. So this is what you expect. But let's say during that business time, something happened, and you ended up making a profit of, instead of 100 naira, you ended up making 80 naira. 80 naira. So this is what you actually got from the business. But based on your calculation, this is what you got. So that thing you actually got is what we call actual yield. Actual yield. Based on your calculation, that thing you expect is what we call theoretical yield. So what does that mean? During the reaction, there's a particular amount of the substance we expect. That particular amount we expect, based on our calculations and based on the reaction itself, is what we call theoretical yield. But during the course of the reaction, so many things might happen. So what we eventually get is what we call the actual yield. So take note, there are two concepts: actual yield, which is what you will truly get at the end of that reaction. Then theoretical need, what we expect, the maximum amount of that substance we expect to get at the end of that reaction. So two concepts: theoretical yield and actual yield. So in your exam, one good question you could be asked is to calculate what we call the percentage yield. How do you calculate? It's very simple. So formula for percentage yield. So percentage yield, the formula is the actual yield over theoretical yield times 100. So this is basically how you calculate what you call the percentage yield. So let's take a question and then simplify this particular concept. So we'll take this question. The question says 50 gram of CaCO3 was heated and produced 20 gram of CaO. Calculate the percentage yield of CaO. So this is the question we are going to look at. When it says 50 gram of CaCO2 was heated and produced 20 gram of CO, calculate the percentage yield of CaO. So in some example, you just say calculate the percentage yield. So you just stop like at this point. But you usually say yield, what are you getting? So yield amount to the product. So let's write the reaction first. So the reaction for this is CaCO3, and this reaction will go down to give us CaO plus CO2. So this is what this reaction will give us. So again, like I told you in some exam, you will not be given this part. I added this part during the course of writing. Do you say calculate percentage yield? So you will not start wondering, or you should not be left confused and be asking yourself, which of them? So in this case, you know that this is the reactant, so this is the product. They didn't even talk about this one. So it means you are calculating percentage yield of this, even if you are not given, because the yield is just like the product, what you get at the end of that reaction. So now let's look at it. We are going to calculate again. from our previous calculation, this was 100 gram, and then this is 56 gram. That's from our previous calculation. Or was it 56? Yeah, 56 gram. So we have 100, we have 56 grams. So based on the standard, and the standard is from what? This balanced chemical equation. So let me just write that back. Standard. So based on the standard, 100 gram of calcium trioxocarbonate we produce 56 gram of calcium oxide. But the question is asking us, if we hit 50 gram of this, what do we expect? So what we expect is what we call theoretical yield. But now this thing actually gave us 20 grams. So this is already the actual yield. But you will get theoretical yield based on stoichiometry. So given, so let's take given. So we have 50 grams. So if we hit 50 grams, what do we actually expect? So let's say x. So that's a simple concept. So cross multiply. Now when cross multiply, we have 100 times x give us 100x. Then 56 times 50, we are going to multiply that. So we have 56 times 50. That will give us 2,800. So this will give us 2,800. So when we divide both sides by 100, divide both sides by 100, x will give us 28 grams. So now, looking at this stuff, it's a very easy concept. Now, from what we expect based on the normal standard is that if we hit 50 grams of CaCO3, we should end up getting 28 grams. So what we expect based on calculation is what we call theoretical yield. So theoretical yield in this case is 28 grams. That's the theoretical yield. Now, but the actual yield is what we actually get on heating. We got 20 grams. So the actual yield is 20 grams. 20 grams. So now let's calculate what we call the percentage yield. Now this is our formula for percentage yield. Formula for percentage yield. So let's go. Percentage yield will be the actual yield in this case, which is 20 grams, over the theoretical yield, which is 28 grams, times 100. So percentage yield will be, we are going to divide now so I can get our final answer. So that will give us 20 divided by 28, and that will give us 71.4%. So the percentage yield is 71.4%. So that is just the simple concept. So again, remember, actual yield is what you get. The theoretical yield is what we actually expect based on our calculation. So this is how we calculate what we call percentage yield. Again, the formula is actual yield over theoretical yield times 100, because it is in percentage. So with that being said, we move on to look at what we call the concentration formula. So there are two basic formulas. We are just going to look at how they are related, and then we'll move on to other aspects. So we are going to look at concentration formula. So that's the concentration formula. That's what we are going to look at. Now, what's concentration, by the way? I want to talk about concentration. It's very simple. I remember as a child, growing up as a child, whenever I'm giving drinks, do you know what I'll do? I'll take that drink and then add water to it. Now, when I add water to it, do you know what I've done? I have turned that drink from being concentrated to being dilute. So, question, what does question actually mean in real sense? It simply means what's the amount of the solute that is present in a particular solvent. So, just like taking water, let's say 2 drums of water, 2 drums filled with water, and then one of the drums added just a spoon of salt, and then the other one added 10 packs of salt. When we feel salty, but one, you won't even feel the salt. Me in one, I have a lot of the salt in it. The other one, which has just a spoon, is dilute. I have very little amount of the salt in it. So in chemistry, we define concentration as the amount of solute present in a given volume of the solvent. So now look at it. So concentration is the amount of solute present in a given volume of the solvent. So this is a basic definition for concentration. So there are two key things you see here: solute and solvent. Now what does it mean? We know what solute means. Solute is whatever you are trying to dissolve. Then solvent is what you are using to dissolve that solute. So just like in chemistry, you say solute plus solvent. Their combination will give us what we call a solution. It's just like we have salt. Salt is a solute. Then we have water. Water is a solvent. And when we have water, then it gives what we call a salt solution. So salt is solute, water is solvent. Combination of them give us a salt solution. Similarly, just like we have sugar and then we have water, it gives us a sugar solution. So now coming back to concentration is simply the amount of the solute. That's where our formula comes out from. So in essence, so concentration is the amount of the solute. So amount of the solute. Now, what do you for measure amount of the solute over the volume of the solvent? Now, amount, the unit for measuring amount of a substance is called moles. So this is like moles over the unit for volume in this case is dm cube. So this is one of the type of condition formula we have. So when we are expressing amount in moles, we call this kind of condition, we call it molar concentration. Molar, take note of this. So molar concentration. For molar concentration, the unit is what we have here. The unit is moles per, you see they're writing as mole per dm cube. Or in more recent exam, it is written as capital M, which is molarity. So if I say 0.5 mole per dm cube, it is the same thing as 0.5 molarity. So this is what we call molar concentration. So when you express the amount in moles, we call that molar concentration because there's another type of concentration. And in most of the exam, you use molar concentration. So you keep hearing about molar concentration. So molar concentration is just simple. The amount of the solute in moles over volume of the solvent in dm cube. So that gives you your unit as mole per dm cube or molarity, as the case may be. Now, in a case where the amount is measured in grams, you get to see case like that. So let's say in this case, so I'll modify this entire part. So our first type of concentration formula is what we call molar concentration. You see it from name, molar to mole. Just use that to remember. So now let's look at the second case. Second case is when amount is expressed in gram. So in some case, this could be expressed as grams over this dm cube. So when you have it expressed in grams, grams is talking about mass. So this concentration is now what we call mass concentration, no longer molar concentration. So for mass concentration, the unit for measuring it is what we call gram per dm cube. So this is just the basic stuff. So for molar, it is mole per dm cube of molarity. Then for mass concentration, it is gram per dm cube. So before we leave concentration formula, I will give you a relationship between molar concentration, mass concentration, and molar mass. So now let's just take a quick look at that. So and then we'll solve the question. So for there's a relationship. The relationship is this. The relationship is that mass concentration is equal to molar concentration times molar mass. So this relationship between the three of them is that mass concentration is equal to molar concentration times molar mass. Now, something very unique because some students easily find this difficult, but for me, I just crafted an easy way to remember. There's mass on one side and the molar on one side. So with that, I can easily tell that mass concentration is equal to molar concentration times the molar mass. So take note of that, the mass on one side and the molar on one side. So now let's take a question. So quick question. Quick questions. Let's say calculate the mass concentration. Calculate the mass concentration of 0.5 mole per dm cube of sodium chloride, NaCl. So in brackets, sodium is 23, and chlorine is 35.5. So let's take this as a question. Let's calculate the mass concentration of 0.5 mole per dm cube. Now, mole per dm cube, you tell that is molar concentration. For the molar mass of this, we don't have it, so we have to calculate. So let's calculate. So for molar mass of NaCl will be sodium, which is 23, plus chlorine, which is 35.5. And then when we add this up, we are going to end up having 58.5 gram per mole. Now for the molar concentration, we are given a question. So the molar concentration from the question is 0.5 mole per dm cube. Now we are told to calculate the mass concentration, and up here we have a formula for mass concentration. So for mass concentration, the formula is molar concentration, which is 0.5 times molar mass, which is 58.5. So we are going to multiply and again get our final answer. So we have 0.5 times 58.5, and this will give us an answer of 29.25. Now, mass concentration is not measured in mole per dm cube, rather it's measured in gram. Just always think about the name, mass, gram. So that will be gram per dm cube. So this is the final answer. So in this concept, in this aspect, we have looked at what mass concentration is, we have looked at what molar concentration is, and then we have looked at the relationship between mass concentration, molar concentration, and then molar mass. So with this being said, if you have any question, please do it to leave them in the comment section somewhere within this live class, and then I'll go back and check if there are questions so that I can provide answers to them. So when we come back, we are looking at two more aspects of this particular class, which is titration formula and then dilution formula. So in the absence of any question, we'll go on and look at dilution formula and titration formula. But before we look at these two, we just have to understand this concept again, because we might find them important in titration formula. Again, remember that mass concentration is equal to molar concentration times the molar mass. Please don't forget this aspect. Very, very important. So now let's move on and then let's look at, we are going to look at dilution formula before we look at titration formula, because that's way easier than titration formula. So now let's move on. going to look at what we call the dilution formula. So what's dilution and then what's dilution formula? Now when we say to dilute, just like taking a substance. Let's say we have a can, a plastic can of water, and that plastic can of water, we poured a pack of salt. That water will be so salty. In chemistry, we say it is concentrated. Now if I take that can of water and then I have a big drum and I empty the entire can into that big drum, what will happen? The salty nature will reduce. And what have I done? I have diluted it. So when we talk about dilution, it's just simply reducing the concentration of a particular solution by adding more solvent. So that's dilution. So there's a formula for calculating what the concentration would be. It's just like having a can. So let's say we have a soft drink. Let's say we have a soft drink here. This soft drink, we have a particular concentration. So let's say C1, it has a concentration, and that is a particular volume. So let's say V1. Then we added water to it. It's now at this point. So at this point, the concentration will now change. We are going to have a new concentration, C2, and then we are also going to have a new volume, V2. So we are going to have a new concentration, and we are going to have a new volume. But then one thing has not changed. And what was that thing that has not changed? The mass. The mass of the substance. So if I have just 50 grams of the salt inside here, it's also going to remain 50 grams of salt. What I only altered is the volume of the solvent, which is water in this case. So concentration will change, volume will change, but mass will not change. If you remember our very first concept, which is based on chemical equation, we talk about what we call the law of conservation of mass. I'm not going to alter the mass of that salt, not because I'm adding water, meaning the salt will increase. That does not happen. So one thing does not change, which is mass. Now in chemistry, the relationship is that concentration, there's a relationship between concentration, mass, and volume. Concentration is equal to mass over volume. This is the relationship. So we are saying we have C is equal to M over V. Now when we cross multiply, we are going to have CV is equal to M. So now what does that lead us to? It leads us to the fact that the mass before dilution is equal to the mass after dilution. Simple. So the mass before dilution is equal to the mass after dilution. So now let's look at something. So this is it. So we have mass before dilution, mass before dilution is equal to the mass after dilution. And I told you that mass is equal to concentration times volume. So before dilution we have C₁V₁, after concentration we have C₂V₂. So simple. So this formula is what we call the dilution formula. So but there's something very tricky. And what's the tricky thing? The tricky thing is our V2. Now when we take questions, you get to understand this better. But now let's explain something that is very unique about the V2. The V2 is that now we have a container here. We have a certain volume, V1. Then this is a new volume. This is a new container. We have a particular volume, V, to give us our new volume. So we have this container here. There was a particular volume of water inside originally, which is V1. Then to dilute, we are going to add more solvent. So V is whatever we are adding. So now the tricky thing you ought to know is that your new volume, V2, is equal to this originally plus this you added. So an additional tip you ought to know is that your new volume, V2, will be the initial volume, V1, plus whatever volume of water or any solvent you are adding. So let's take a question to simplify this aspect. So let's see if I got a question here. Okay, good. Okay, I don't have a question here, so that means I'm just going to generate something for us. So now let me generate a question. So question, or I'll clean this off the board. So let's see. So the question is 250 cm cube of water is added to 500 cm cube of So this is the question we are going to look at. The question simply says 250 cm of water is added to 500 cm cube of 0.5 mole per dm cube of HCl. The question says calculate the new concentration of HCl after dilution. So now we added 250 cm cube of water. We added it to an original volume which is 500. So our V1 is 500 cm cube. And the concentration of 500 cm cube of HCl is 0.5 mole per dm. So C1 is 0.5 mole per dm cube. Now this is a mistake, like I said earlier, that students make. The mistake is that students will take this as V2, which is wrong, because you are adding 250 to 500. Your total volume after dilution will be this plus this and not just this. So V2 will be 250 plus 500, and this will give us 750 cm cube. So it's very simple. Originally we had 500 cm cube, so we added 250 cm cube. So the new volume will be 750 cm cube. Now the question is telling us to calculate the new concentration, which is C2. Again, what's our formula? Dilution formula: C₁V₁ is equal to C₂V₂. But mind you, we are looking for C2, so I'm going to make C2 solve the formula. So when we do that, C2 will be equals to C₁V₁ over V2. So that's simple. So I just made C2 the subject of the formula. So as a subject of the formula, we are going to have it just like that. So now let's go ahead and calculate. Now C2 is equal to C1. C1 from the question is 0.5 times V1 from the question is 500 over 750. So let's calculate. So C2 will be equals to, so let's do a calculation. So we are going to have 0.5 times 500 divided by 750, and our final answer is 0.33. Remember, we are calculating for concentration, that's mole per dm cube. So 0.33 mole per dm cube. So that's just how we look at dilution and the dilution formula. So the formula is C₁V₁ is equal to C₂V₂. But like I said, mind you, when you are solving questions, take note of that V2, because V2 is not just the second volume you can see. It's a combination of the volume you are adding plus the existing volume. That will give you your new V2. So with that, you can calculate anything you are looking for with your dilution formula. So the last thing on our outline is the titration formula. So let's go and then let's solve questions. So the last aspect of this class is the titration formula. So for a titration formula, we have to understand in this light, we've looked at how to balance chemical equation. We are going to need it in this aspect. We've looked at the relationship between molar concentration, mass concentration, and molar mass. We're also going to need it in this aspect. And also we've looked at what we call those limiting and excess reagents. We might need it here. Now, for a titration formula, what's titration? What about titration? It's just a process, a technique where you run an acid in a burette. You run a base rather in a burette against an acid. So you run an acid in a burette down to meet a base. Now that process is what we call titration. You are like adding them in bits till you achieve your end point. So now titration is more commonly referred to reaction between an acid and a base, but it's not just acid and base that can undergo titration. Even an acid and a triazocarbonate can undergo a titration reaction. So we'll talk about the two of them. Now for your exam, this was more relevant. You have to know what will they give you at the end of the day, and you have to know how to balance it. So whenever an acid reacts with a base, so acid plus a base will give us what we call salt and water. Salt and water. So let's take a typical example. So let's say we have HCl plus we have NaOH. When they both react, it will give us what we call NaCl, which is a salt, and then water. So we have an acid, hydrochloric acid. Then we have a base, sodium hydroxide. When they react, will give us salt, sodium chloride, and water. So typically, whenever an acid and a base react, you will always form two products, and those two products are salt and water. Take note. Then for the second titration aspect is an acid reacting with what we call a trioxocarbonate. Carbonate 4. Now when this reacts, you are going to form three things, or let's say you are going to form one additional thing to this, which is carbon dioxide, because of this carbonate here. So you are going to form salt, you are going to form carbon dioxide, you are going to form carbon dioxide, and then you are going to form water. So the difference between acid reacting with triazocarbonate and acid reacting with base is that you are going to form an extra substance here, which is carbon dioxide. So let's take a typical example. Let's say we have an acid, HCl. We have a triazocarbonate, Na2CO3. We are going to form an acid, a salt rather, in this case NaCl. We are going to form carbon dioxide, CO2. We are going to form water, H2O. So this just is different. So the first thing is that for titration formula, you want to know these two aspects. It's either an acid reacts with a base to give you salt and water, or an acid reacts with triazocarbonate to give you salt, carbon dioxide, and water. So in all of them, whatever one you have, we will treat acid as acid, and then we'll treat triazocarbonate as what? A base. So when you see us writing CB, we can also refer to triazocarbonate as a base in this case. So we treat acid as acid, we treat base as a base, we also treat a triazocarbonate as a base. So now what is the titration formula? Now let's take a look at it. So this is the titration formula. So the titration formula is C1 or Ca rather, C1 is for dilution formula. So CaVa over CbVb is equal to Na over Nb. Now what do they stand for? Ca is molar concentration. We didn't say mass, molar. Molar concentration of the acid. Molar concentration of the acid. Then we have Va, volume of the acid. Volume of the acid. We have Cb, molar concentration again, not mass. So if you are given a question that has to do with titration, and you are giving mass concentration, you must convert that mass concentration to what? Molar concentration. Using the formula I gave to you earlier, which is mass concentration is equal to molar concentration times molar mass. So molar concentration of the base, molar concentration of the base, then Vb is equal to volume of the base. Volume of the base. Then Na is number of moles of the acid. Then Nb is number of moles of the base. So the titration formula is CaVa over CbVb is equal to Na over Nb, where each of them have what they stand for. Ca is molar concentration of the acid, Va is volume of the acid, the A here just stands for acid, the B stands for base. Then CB is molar concentration of the base. Mind you, we have molar concentration, not mass concentration. So if you are given a question where you have mass concentration, ensure that mass concentration is converted to molar concentration, and there's a formula for that, which is mass concentration is equal to molar mass times molar concentration. So VB is volume of the base, Na here is number of mole of the acid, and NB is number of mole of the base. And you can only get these guys from a balanced chemical equation. That is where balancing of a chemical equation becomes relevant. So you can get those two from a balanced chemical equation. So if the equation is not balanced, you will get a wrong Na and a wrong NB. So your equation must be balanced. So now let's solve a question and then we'll call it a wrap for today's class. So that's a simple question we are going to consider in the course of titration aspect. So the question is simple. What volume of 0.5 mole per dm cube of sodium hydroxide will react with 0.25 mole per dm cube of 25 cm cube of HCl? So for HCl, we have everything here concerning HCl. So for NaOH, we have just this for NaOH. So when you are given a question like that to do titration, you have acid, you have a base. The first thing you do is to write out your chemical equation. And like we established earlier, we said acid and base, whenever they react, that reaction is what we call neutralization reaction, and you produce two products, salt and water. So now, for this reaction, we have HCl plus NaOH. Now, when they both react, you are going to get NaCl plus water. And when you take a look at this reaction, the reaction is balanced because we have one atom of hydrogen here, one atom here. So in total, on this left-hand side, we have two. On the right-hand side, we have two. For chlorine, one atom here. For sodium, one atom. For oxygen, one. So with that, this equation is balanced. So like I told you, it's from your balanced chemical equation, you can tell Na and Nb. So now let's write out our formula. Our formula for titration is CA₁VA over CB₁VB is equal to Na over Nb. Now Ca is concentration of the acid, and for HCl is the acid. Concentration of the acid is 0.25 mole per dm cube. So Ca is 0.25 mole per dm cube. Now, then we have Va, volume of the acid. We are told that is 25 cm of HCl. So Va is 25 cm cube. Now, Cb is concentration of the base, and we are given here 0.5 mole per dm cube. So that's 0.5 mole per dm cube. So next is Vb, volume of the base. That is the question itself. It says what volume of this base will react with the acid. So the volume of the base we can't tell until you calculate. Next is Na and then Nb. So when you balance your reaction, you check number of mole of the acid here is 1. Number of mole of the base here is 1. In this case, it is 1. In some cases, you can have probably 2, 3, as the case may be. So now we are going to calculate the volume of the base. So we are looking for Vb. In Waec or in SSC, make Vb solve the formula, and I'll do that right away. So if you don't know how to make something solve the formula, do have to check on my last video lesson. I have released a video lesson on change of subject formula. So with that, you should be able to make Vb the subject of the formula. So I'll quickly do that. So Vb will be equals to CA/VA/NB over we have CB/NA. So we are going to go ahead and calculate. So volume of the base will be concentration of the acid, which we have here as 0.25. So that is 0.25 times VA, which we have here as 25, or rather, yeah, 25, times NB, which we have here to be 1, over CB is concentration of the base, which is 0.5. So that is 0.5 times NA, which is 1. So we're going to go ahead and calculate. So VB will be equals to, I'll multiply the numerator and also multiply the denominator. So that will give us as 0.25 times 25, and that will give us 6.25 for the top. Then for the denominator we have 0.5. So finally, volume of the base will be final answer will be 12.5. We are using cm cube. So final answer will be cm cube. So 12.5 cm cube. So please do try to recall the Titration formula, which is CAVA over CBV is equal to NA over NB. Now the B stands for base, but it's not only limited to base. It can also be what? A trioxocarbonate. So scholars, I believe you enjoyed this class and you found it interesting, you found it comprehensive and expository. So if you have any question, do it to leave your questions in the comment section beneath this video lesson. And if there are any comments or suggestions, also do it to leave them, as I'll do it to follow up all questions, comments, or suggestions after this class. And if you are new here and you are watching this video for the very first time, or you just came across this channel, do it to give this channel a thumbs up, and also do it to subscribe, so that you always get notified whenever I release a new video. So till you get to see my next video, or you get to join my next live class, do have a wonderful evening.